Laser powder bed fusion is a dominant additive manufacturing technology that has yet to reach its potential. The problem facing industry is that tiny bubbles or pores sometimes form during the printing process, and these pores create weak spots in finished products. When a slow-speed, high-power laser is melting metal powder during the 3D printing of a part, a keyhole-shaped cavity in the melt pool can result. Pores, i.e. defects, form at the bottom of the keyhole. New research published in Science reveals how the pores are generated and become defects trapped in solidifying metal. The real practical value of this research is that we can be precise about controlling the machines to avoid this problem, says Anthony D. Rollett, a professor of materials science and engineering in Carnegie Mellon College of Engineering and a lead co-author of the paper, Critical Instability A. Pores form during fluctuations of the keyhole, and it changes its shape. The keyhole tip morphs into a J shape and pinches off. This unstable behavior generates acoustic waves in the liquid metal that force the pores away from the keyhole so that they survive long enough to get trapped in the resolidifying metal. The team is the first to focus on this behavior and identify what is happening. When you have a deep keyhole, the walls oscillate strongly. Occasionally, the oscillations are strong enough at the bottom of the keyhole that they pinch off, leaving a large bubble behind. Sometimes this bubble never reconnects to the main keyhole. It collapses and generates an acoustic shock wave. This pushes the remaining pores away from the keyhole, explains Rollett. It's important to note that keyholes themselves are not flaws and, e.g., they increase the efficiency of the laser. Using synchrotron X-ray equipment at Argonne National Laboratories, the only facility in the United States where the researchers could run these experiments, they noted that there is a well-defined boundary between stable versus unstable keyholes. As long as you stay out of the danger zone, i.e., too hot, too slow, the risk of leaving defects behind is quite small, says Rollett. Fluctuations in the keyhole's depth increase strongly with decreasing scan speed and laser power on the unstable side of the boundary. You can think of the boundary as a speed limit, except it is the opposite of driving a car. In this case, it gets more dangerous as you go slower. If you're below the speed limit, then you're almost certainly generating a defect, adds Rollett. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.